All right, welcome to the lunchtime video. Last video, we looked at enabling authentication for IPv6 OSPF version 3, which you have to have version 3 for IPv6. Version 2 is only capable of IPv4. In addition to that difference, there is another pretty large difference between OSPF version 2 and OSPF version 3, and that is how the hello packets can be authenticated in OSPF version 2. You can use a mechanism within OSPF version 2 to have authentication parameters included in the OSPF header. So if you take a Wireshark capture, and you look at, you'll see the frame section, Ethernet, IP, OSPF. You also click into the OSPF section to see the password. That's quite a bit different from OSPF version 3 because there is no built-in authentication mechanism in OSPF 3. So what you can do is you can use an external mechanism called IPsec, which is to enable authentication for the IP header of the packet, and then you don't have any authentication at all on the OSPF section because it's already done in the IP header. So we saw after enabling that unlike version 2, where you see the hash in the OSPF section of the Wireshark capture, it's going to be in the IP section because we're using that extra mechanism, IPsec. We're defining our IPsec configuration, and then when it comes to the OSPF configuration, instead of in OSPF 2, instead of adding the authentication configuration there, we're just pulling in the authentication configuration that we added in the IPsec section because it relies on that external mechanism, unlike other protocols. But it wasn't too hard to figure out how to set up. I was even able to just stick to help apropos. I didn't even need to pull up any extra web documentation, which is always good because I won't have free access to the web during the exam. From what I understand, I'm going to get a few help docs, so I'll be able to use a web browser, but I won't have free access to the internet. So the better use I can make out of help apropos, the more resources I have available to me on the test in case I were to get stuck. Okay, but we're moving on to a new topic today because I got that finished. So let's take a look at what the new topic is going to be. Okay, so we're still going to be learning about configuration and troubleshooting for IGPs, but we have finished authentication. It looks like I already marked it as done. So now we'll be looking into level/area mismatches. So that's a clue right there that we're going to be having to look into two different IGPs, ISIS and OSPF, because in OSPF you have areas, in ISIS you have areas as well, but you have levels. So we'll take a look at a area mismatch in OSPF version 2 and take a look at the trace options files and see if we got any good clues that can let us know right away on the test what the issue is. And then on ISIS, we'll try to create a similar thing for areas as well as for levels. All right, so let's copy over the title and make the notes folder. Okay, so this is going to be, instead of authentication, it's going to be level area mismatch. Let's go rename, copy. There we go. And this is going to be the first video. So all these first tags are going to apply to every video. Linux, maybe not so much. But I might be using the jump server, and then of course Junos OS is based off of FreeBSD Linux, so I think it's appropriate to still have in there. IGP, of course, T-shooting, yep. IPv6, maybe not so much. Network security, maybe not so much. So I think I'm just going to stick with these tags. Oh, it looks like I've been tagging my videos OSFP instead of OSPF. Well, whoops. Okay, so let's do the strategy that I wanted to utilize for all future videos. And let's start with the help apropos and see if we can find any documentation for mismatch. All right, so we'll open up router 1 and router 2. And we'll detach router 2 and put them side by side. Okay, we'll log into router 2. All right, so let's do a help apropos. Mismatch, pipe match, help. All right, so I don't see anything there. So let's try area. Ah, here we go. We got lots of stuff. Yeah, this is something we could do as well, is look at what happens when the types of areas in OSPF mismatch. We know we've got regular areas, we've got stub areas, we've got not so stubby areas, we've got totally not so stubby areas, and we've got totally stubby areas, I believe, are the 5 areas for OSPF. I think I will, well, let's see if we can find confirmation of that in the documentation. Yeah, so let's start here. Ah, okay, so the regular area is actually called the backbone area. So let's see if I got that right, that there are 5 different stub areas, well, 4 different stub areas, because the backbone area is not going to be stub area. So that there's four stub areas. There's a stub area, there's a not so stub area, there's a totally stubby area, and there's a totally not so stubby area. I'm not sure if I have that right. And if you're new to the channel, you might be thinking, oh, well, I'll just use Google. Well, the point of this is to pass an exam where I won't have Google. So if I can figure it out using the resources I will have, I'm going to take the exam. That is a better way. Because if I ever have a question like this during the exam, I'll be able to get my answer. I mean, one really easy thing I can do to figure it out is just do, here we go. So here's, no, well, this is just for not so stubby areas. But we can figure it out just by going configure private, edit protocols, OSPF. So area, so it won't be in area 0 because area 0 is always going to be a backbone area. So if we want to figure out what kind of stub areas we can make a non-backbone area, we're going to need to go into the hierarchy menu for a non-backbone area. Okay, so we've got not so stubby areas. We've got stub areas. But you can see we've also got the option for either summaries or no summaries. So, yep, there's 4 of them. I believe I was right. There's the not so stubby area. There's a stub area, or the stubby area. And then there's the not so stubby area with summaries, which I believe is the default, with no summaries, which would make it a totally not so stubby area. And then there's the stub area with summaries, which is the default, I believe, for this as well, and with the no summaries. So, yep, you've got 4 different types of stub areas, but you've got a total of 5 different areas because you've also got the backbone area, which is not a stub area. So 4 different kinds of stub areas. And let's do a quick Google search just to make sure that that is right. We won't have the ability to do that during the test, but network lessons. I really like network lessons. Yep, so I was correct. 4 of them. Stub area, not so stubby area, totally stub area, totally not so stubby area. 4 of them. All right. So let's see which IGP is configured right now. So show configuration, display set. No more. Okay, so right now we've got OSPF area 3. So let's do this. Let's configure one of our routers to be in a different area. So we're going to have our backbone area. But I think our backbone area, we're going to have, I'd like to make these the backbone area. Yeah, so let's make router 2, router 3, router 4 a part of the backbone area, but then let's make router 1 be in its own area and take a look at what a mismatch we'll see by doing that. So let's go into router 4 and run the trace options. Oops, so we got the bug where I lose the command line, unfortunately. Yeah, so nothing I can do here, as far as I know. All right. So that's kind of too bad. I mean, it only takes 6 minutes to boot up. I timed it, the last one, but you know what? Let's do that just because it's only 6 minutes, and 6 minutes now is better than 6 minutes later because I'll get more time after it's ready to go. If I do it now, then I will if I do it later. And I just don't know how useful time is before it's ready to go. So I'd rather have that time be restricted to as close to these 6 minutes as possible. All right, so 6 minutes from now at 12:25, everything will be good to go. But let's try to make decent use of that time beforehand. So let's just Google ISIS Level Mismatch. Okay, so we've got some good things going on here. Now let's Google Area Mismatch. Okay, interesting things here as well. Oh, so we got some time-saving techniques. This only is good. All right, now let's switch it to OSPF. And let's do level mismatch because there shouldn't be any results. Okay, so we've got some interesting results, but it's due to other things that will be useful. Here we go. Here's some. Yeah, here we go. Troubleshooting questions. Yeah, here's some interesting stuff. Okay, now let's do OSPF area mismatch. All right, so let's look into these links. And then let's take some notes. So to do that, we'll just fill in the fill in what is there. So I'll detach that. And then if it's a really good link worth saving, I'll put the link here. Maybe even add a note. Here we go, troubleshoot. There's currently no specific troubleshooting information available for this configuration. So really don't think this is going to be useful to me because I would like that. Well, let's read about ISIS areas because this is going to be, yep. And then hopefully if they have something for levels, we can read that too. Yeah, so let's read everything here. All right, ISIS areas. In OSPF protocol, any of the router's interfaces can be assigned to a particular area. However, the concept of area in ISIS is different. Here in general, every single router belongs to an area. The idea of this comes from the fact that ISIS was initially created to route connectionless network protocol, CLNP, where the address belongs to a device router, whereas in Internet protocol, which is used by OSPF, ISIS, as we just read, initially was created to use Connectionless Network Protocol, CLNP. The address belongs to a particular interface. ISIS protocol has two levels or hierarchy, level 1 and level 2. Level 1 corresponds to OSPF intra-area routing, whereas level 2 corresponds with the OSPF backbone area 0 routing. Level 2 areas join all areas with the backbone area. Every Cisco router, these are Juniper routers, but it's an open standard protocol, so it should be the same, comes by default as level 1-2 router to allow for easy configuration and deployment. A level 1 router can become adjacent with the level 1 and level 1-2 L1/L2 router. A level 2 router can become adjacent with level 2 or level 1-2 L1/2 router. There is no adjacency between L1 only and L2 only router. What? Oh, okay. So, and that makes sense. So let me pull up Paint, make sure I've got an understanding of this. So we've got two routers here, and these are for ISIS, so they're connected together. So let's say that this is level 2 and that this is level 1. So yes or no, 3, 2, 1. Well, I'll give the countdown after I ask the question. So yes or no, will there be an adjacency between these two routers? 3, 2, 1. The answer is no, because you can't have an adjacency between purely level 2 and purely level 1. Because because it's not IP protocol. It's not using IP protocol. It's using CLNP, some special network protocol specific to ISIS. So it's one of its advantages because it's seamless for IPv6. It's seamless for older gear. It just works a lot better in cases where you have alterations to IP protocol, such as using version 6 or certain devices not using IP protocol. That will break your OSPF configuration, but your ISIS configuration will run seamlessly. All right, so the answer here is no, and let's get a better understanding for why. So if it were OSPF, what we could do is we could say, okay, well here's an interface with a link. Here's another one, another one, another one, another one. This I want to be in area 1, but all these in area 0. So you can't do that with ISIS because the ability to do that is a feature of IP protocol, which ISIS does not use. So all you can do is you can say, I want this whole thing to be in, so this whole thing here to be a level 1 router. You can only specify what the entire router is itself and not what certain interfaces are. So you could not connect a level 1 router to a level 2 router. But a situation like this, you can get around because you can say it's either a level 2 router or a level 1 router. In addition, you've got a third option that can say, this is a level 2 and a level 1 router. So in ISIS, if we had a situation like this, it would be perfectly valid to have a connection as long as this were a level 2-level 1 router. We could connect it up to a level 1 router here, level 2 router here, level 2, level 1 router, whatever we wanted. But of course, we're going to need to make those choices on the requirements of our topology. All right, so hopefully that's clear enough. Let me know in the comments if it's not. I think this is worth saving for a brief explanation of ISIS areas and why they are different from OSPF areas. So they are different from OSPF areas because ISIS routes connectionless network protocol, but OSPF routes internet protocol. So because of that, OSPF can do it per interface, but ISIS only has the ability to do it per router. ISIS level 1 L1 router. An ISIS level 1 router has the link state information of its own area for all the intra-area topology. In order to route packets to other areas, it uses the closest level 2 capable L1/L2 router. And this is a good point too, this L1/L12, because this closest level 2 capable router, which has to be a L1/L2 router, because if it were a purely L2 router, it could not form an adjacency with it. So it can only route packets to other areas by way of an L1/L2 router. So an L1/L2 router is kind of the equivalent of an ABR in OSPF, but an ABR is not specifically called an ABR, it's just a router with interfaces in more than one areas. ISIS is different because it's not per interface, it's per device. So an ABR is essentially called an ABR by configuring it to be L1 and L2 capable. Level 1 area behaves pretty much as OSPF totally stubby area. L1 only router sends L1 hellos. ISIS-level 1-2 L1-2 router. So this is kind of equivalent to ABR and OSPF. Whereas a ISIS level 1 router is more equivalent to a stub router in OSPF. And ISIS L1/L2 router maintains 2 link state database information. One is for level 1 and the other for level 2. Hence 2 distinct shortest path. First, SPF calculations are run. One on level 1 link state database and other on the level 2 link state database. ISIS level 1-2 router behaves very close to a OSPF area border router, called it. Level 1/L2 router sends both L1 and L2 hellos, which we saw. In addition to that, it also forms 2 adjacencies. So if you're forming an adjacency from a L1/L2 router to an L1/L2 router, you're going to have 2 adjacencies, one across level 1 and one across level 2. If you form an adjacency to a purely level 1 or level 2 router, in that case, you will only have 1 adjacency because you have an adjacency per level, where an adjacency is capable of being formed. As default behavior, L1/L2 router will only allow one-way passage of prefixes from L1 area to L2 area, but not in reverse. Okay, so that's interesting. I actually did not know that, so that's going to be helpful to know. So I will add that to my notes. However, if it is required to move prefixes from L2 area to L1 area, then redistribute command under ISIS configuration is required. I think that's known as route linking. ISIS level 2 L2 router. And ISIS level 2 router has the link state information for the intra area as well as the inter area routing. L2 router sends only L2 hellos. ISIS level 2 areas can be compared with OSPF backbone area 0. Okay, and let's read about authentication as well, because we just finished that. So I'll make sure that the understanding of that lingers over. ISIS can separately authenticate hellos and link state protocol data units, LSP. If hellos are authenticated correctly and LSP authentication fails, the adjacency will come up, but updates won't exchange. So authentication, if configured for ISIS hellos or PDUs, protocol data call unit, must match on both ends. All right, so that's good to know. You've got to separately set up authentication for both hellos and link state protocol data units if you want to fully configure authentication for ISIS. That's something I actually did not know from the last one. Oh, well, it looks like it can do that. I don't know whether or not it does that by default. All right, moving on. Here we go, MTU mismatch problem in ISIS. So unfortunately, this is not for that. This topic is going to be about area and level mismatch problems. But we already did finish the MTU problem. So let's go back and review. It's always good to review. So let's see here. Yeah, let's just read the introduction. Intermediate system to intermediate system, ISIS hellos are padded to the full maximum transmission unit, MTU size. The benefit of padding ISIS hellos, IIHs, to the full MTU is that it allows for early detection of errors due to transmission problems with large frames or due to mismatched MTUs on adjacent interfaces. The padding of IIHs, ISIS hellos, can be turned off I don't see where this, oh, this is where it changes. For all interfaces on a router with the no hello padding command is going to be different for Junipers. In routing configuration mode for the ISIS routing process. All right, let's take a look because it's now 11 minutes later than it's required for the lab to reboot. So let's see if we've got the ability to get rid of that padding, just because I'm curious. Oops, so I've got Radius set up, but I don't have my Radius server installed. So it's going to need timeout. you go into radius, but then it's going to fail over to password authentication. There we go. So that's why there's that long delay there. Let's do a configure private, edit protocols ISIS. And now let's see if there's something to do with padding. Thought I saw something. Nope. Don't see anything yet. So this is going to be for the hellos. So let's see if there's anything for the hellos. All right, well, let's see if there's any specific options under the interface hierarchy. Aha, hello padding. So we do have the ability to alter the padding in Juniper just as we do for Cisco. So we can disable it. We can make it adaptive, padding until state of neighbor adjacency is up. We can make it loose, padding until state of adjacency is initializing, which is the state before it goes to up, so it might not necessarily make it to up. Or we can go with strict, padding for all adjacency states. The padding of IIH, ISIS hellos, can be selectively turned off for point-to-point or multi-point interfaces with the no hello padding multi-point or no hello padding point-to-point command in router configuration mode for the ISIS routing process. Hello padding can also be turned off on an individual interface basis using the no IS hello padding interface configuration command. A user would disable hello padding in order to avoid wasting network bandwidth in case the MTU of both interfaces are the same, or in case of translational bridging. While hello padding is disabled, Cisco routers still send the first 5 ISIS hellos padded to full MTU size. This is to maintain the benefits of discovering MTU mismatches. Consecutive hellos are no longer padded. This document demonstrates what happens when there is an MTU mismatch. Okay, so that was actually pretty useful. One thing I did notice in my trace options file. So that was useful enough, I think, to save the link and leave a note. So review of ISIS MTU mismatches. ISIS hellos are padded, and the padding can be modified to preserve bandwidth, but the modifications may result in MTU matches. Okay, so that's something to look out for on the exam for sure. All right, so now we've got the adjacency. Here we go. So this is going to be really useful because we can see if we run this command, show ISIS adjacency, and we have a transition log. If we can look at the down reason, we'll be able to see ISO area mismatch and tell right away if there's a mismatch. And we get the same thing for level mismatch. All right, so yeah, let's take a note of this as well. Oops, transition. It's just a grammar mistake. Or, okay. So transition log, down reason. So area mismatch or level mismatch. Okay, so that would be really, really good to check. And we'll be able to figure out right away without any trace options, anything like that. One command if this is the problem. All right, so yeah, this looks like a really good thing to, yeah, here we go. So tasks to troubleshooting OSPF. So yeah, this looks like a good thing. So let's I'm kind of coming near the end of this video a bit. So let's do ISS checklist. Okay, and then let's make a video for or make the title for the next video. It's gonna be -2. And then let's include all those links I didn't get to. So I got to this one, but I didn't get all the way to this one. So you know what, let's include it. Okay, and then, oh, this looks like you gotta subscribe to unlock. So I don't think this is gonna be useful. Here's the Juno's cookbook. This actually looks like a pretty good book. Might want to pick this one up. Yeah, because it's showing you how to do trace options and stuff. But I think I'm good. So yeah, I don't think this one's going to be useful for me. Maybe the, let's see, this is called the Juno's Cookbook. Yeah. I could get the Kindle version of this. Ah. Yeah, this looks like a good book. So I'll say this with a note. But I think I'm going to take the test. If I fail it, maybe I'll pick up and invest it and do a retake on the exam. But you know, that's a lot of money. It's already gonna cost me like $3,000 to take the exam, and I don't think my current employer has a bonus program for it like my last employer did. But you know, as I said, it's you know, why do people do the things they do, and is there a good reason for doing that? And I think for me, taking this test, you know, where I was at my last job, it would be, well, obviously there's a bonus program. Test is going to be covered for me. Travel is going to be covered for me probably. And I'm going to get a bonus for it. Obviously, it makes sense to do it, but here it's like, yeah, well, you know what? I don't know what the future is going to be like, but I do know that an expert in Juniper networking is probably going to be wanted in the future somewhere. And if it's not going to bankrupt me, do it. So, of course, that means I only got 1 or 2 shots at it. But if I fail it more than twice, I can always go the other way and get more low-level certs that I can even just take at home and go that way. And of course, I don't have a bachelor's degree either, so I might want to do that eventually. But either that or just do self-learning, because now that it's public on this channel, you know, you don't have to take my word for it. You can go through and look at my channel where I learn about computer literacy. Okay, I don't think this is going to be useful, so I'll close that. This one too is kind of a little bit too cluttered. Ah, here we go. This looks good. Ah, yeah, just looks good. We've got troubleshooting flowcharts for OSPF. We've got some tricky questions for OSPF too. These might be useful. But this is for Cisco, so I think it's kind of a diversion. Okay, so these are the ones I'm going to look at in the next video. Unfortunately, this video is now over. It's 12:54, so I've actually got a meeting at 1. So thanks for watching. I will see you in the next video.